Welcome friends, welcome to the lecture series of digital electronics. So in this lecture session today we are going to learn about the combinational circuits, and the first combinational circuit which we are going to learn, that is our half adder and full adder. So we have seen this before, that what do we exactly mean by combinational circuits, and that is nothing but a combinational logic circuit is one in which present state of the combination of the logic inputs decides the output. Means if you are feeding any input at this particular circuits, then they will be only responsible. Okay, it will not be like that previously it was the bit was 0, then the output will be now 1. So that will not affect its output of this combinational circuit. So we can say the future output, whatever the future output of this circuit will be there, but it will not affect the present output of this circuit, right? So that is called as the combinational circuits, and whichever the circuits are depending on the previous outputs, right, they were assumed that is dependent on the previous output, right? So that is kind of circuits will be called as sequential circuits, that we will see whenever we will come to that topic, right? So the term combination logic means combining of two or more logic gates to form a required function where the output at a given time depends on the input, right? And required output data is obtained from this process by transforming the binary information given at the input, right? So this way it could be. So let's get into the half adder first. Yes, so then half adder is a combinational logic, right? So that we will see how it is combinational, right? It will be of two combination, different combination. One is our OR gate and second is our AND gate, right? So in this way it is a combination. Half adder circuit is designed to add two single bit binary number A and B, right? And it is the basic building block for addition of two single bit numbers, right? This circuit has two outputs, carry and sum. One we need to think about, that is our total sum, and if the sum is persisting more than the particular limit, then it will be generate a carry, right? So that carry will also be seen at the particular output. This one be my block diagram, and this way it can be understood that we are providing two different digits A and B, and it will be giving some output as an sum, and if the sum goes around a particular value, then it will be generating a carry, right? So for the truth table, if you remember the binary digits and the Boolean algebra laws, then you definitely get this conditions, that how it is being taken place. So see, first for the first case, 0 plus 0 is nothing but 0, and the carry will be 0, right? For the second case, 0 plus 1 equals to 1 and the 0, right? So 0 plus 1 is equals to 1. 1 plus 0 is also equals to 1, and 1 plus 1 equals to 1 0, right? So 0 will be the sum and 1 will be the carry. So that's all for this half adder, and if you get this thing, then you should definitely get the what is the basic idea behind this half adder. See, this is adding only the half bits, right? Not adding the carries. So that's why it is called as the half adder. Okay, so this way it can be understood, and this way the half adder can be justified. So here you can see this is a circuit diagram of the half adder. Two inputs are given to the OR gate, and the outputs from this A and B only will generate a carry at the condition of this AND gate, right? So this way it can be represented. Let's check how it will be working for the full adder. So over here, if we check for the full adder, then a combinational circuit that performs the addition of 3 bits. Now what we are doing, we are taking the carry in also. Whatever the carry we should provide, it will generate the total output at the sum with the carry added and the carry out, right? If still carry is generated, then it will become as this condition on this output condition. So from this block diagram and the truth table, we can able to understand. See, we are providing 0 zeros, then it is all the terms are 0. Not bother to worry. Here you can check if we are providing both the zeros and carry is in 1, then it will be giving 0 as the carry and 1 will be the sum. So now you can check that whatever the carry is here, it is adding towards this particular sum. The total sum of this 0 plus 0 is 0 and 0 plus 1 is equals to 1. So this way it is adding the full complete figure, whatever the figure will be there. So as this way, if you check all these terms, then you definitely get some idea about how it is differ from the half adder. See over here, 0 plus 1 0 is equals to 0 1. Here what we are doing now, carry is 1 and the other digits are same. 0 1 plus 1 is equals to 1 and 0, right? 0 plus 1 is nothing but the 1 and the output will be 0. See, 1 is there and 1 plus 1 is 10, nothing, right? So 0 will be the sum and 1 will be the carry. So this way it can be represented. For the 1 and 0, 0 will be the carry and the output will be 1 as because the carry is 0, so 1 plus 0 is equals to 1. 1 plus 0 is equals to 1 only, but 1 plus 1 is equals to 1 0. So 1 will be the carry and 0 will be the sum, right? So 1 plus 1 that is our again 1 0 and 1 0 plus 0 is nothing but the 0. So carry will be the 1 and the sum will be 0. So this way after that 1 plus 1 is equals to 1 0 1 plus 1. So again it will be, there is 2 carries are generated and it will be located or we can say represented at the output terminals. That is 1 will be the sum and 1 will be the carry, right? So this way complete full adder circuit is being performed. We will check this full adder by using the half adder also, and how it is possible that we will see in next lectures. But up till now all of you are getting the complete idea about this half adder and full adder circuit. This will be the logic diagram for the full adder. Here you are seeing that we are taking an OR gate, and for the carry input we are considering this AND gates. This will be adding the A plus B, this will be adding the A plus C, and this will be adding the B plus C, and all the 3 inputs are provided to this OR gate. So at the CO, that is our carry out, will be giving this much values, right? AB plus AC in plus BC in, and the sum will be over here. So this way a complete full adder can be formed, and from this particular idea all of you are getting that how a full adder and half adder circuit will perform. Still we have some topics remaining for this half adder and full adder, that we will see that how half adder, 2 half adders can make a full adder, right? So it is basically a practical thing, so we will also check this thing, and today we have to do some exercises on the assigned portal that we will see in the classroom, right? So that's all for this particular video. If you gain some of the knowledge from this video, then you should like and share my video. And if you want to see more this kind of videos, then you should definitely subscribe to my channel. Thank you.